Hello, everyone. Welcome to the fourth edition of Newton Speaks, conducted by ISTE NIT Calicut Students Chapter. This is our monthly webinar series where we invite guests who don't just think outside the box, they redefine what the very box is, just like Sir Isaac Newton. Today, we are joined by Sir Ranveer Chandra, who is currently the Chief Scientist at Microsoft Azure Global. We are familiar with Azure. It's a cloud computing software mainly used for sandboxing, mostly building, testing, and deploying managing applications, which are services which are managed through Microsoft data centers. As a list of his accomplishments, I feel it would be easier if I have mentioned the stuff that he hasn't done. Because, okay, so a couple of stuff he has done is he's written a paper on software-defined batteries or SDBs. Basically, it's where the computer controls how much amount of energy comes out of a battery. Most of his work, which I have found quite interesting, was related to white spaces, which I'm hoping Sir will talk about soon. He's started a wonderful initiative called Farm Beats, which actually runs on white spaces, most of it. It's a wonderful agriculture program. And he has also coded the Xbox One wireless control protocol. Before I pass on the mic over, Sir, so people can finally stop hearing me talk, I do have to say, when we saw your massive list of stuff that you have done, it actually blew us away. Like, it's the sort of thing we expect when someone says engineering. All this, like, given, what was your college life like?
My college life?
Yeah.
Yeah, I could talk about my college life too. I went to IIT Kharagpur, and I was I was a computer science student there in IIT, and I had a very interesting time there in IIT. That is the first year when I joined. You know, when first year you all come, you all are brilliant, and everyone in your class is brilliant too. And then you take your exams, and some people will do well, others will not. In my case, when I joined in the first year, I was actually number one in the institute in the first semester.
Oh, okay.
And then my brother came to me and said, my brother was also there. He was in the final year at that time.
Okay.
He was doing metallurgy. He was like, see, you came first. Now you have to, don't do anything else. Just focus on your studies, no politics, no partying and all that stuff. But that was the time, you know, when you all are young, you want to try, and it's good to try things, to explore things, right? That's the time you're growing, not just academically, but you're growing as an individual. So I did everything. I ran for elections. I organized lots of events and all that. Of course, by the end, I wasn't number one. I was number three by the time I graduated. But yeah, I did have a lot of fun in undergrad. So you all should too. I didn't have as much exposure, I think, as these days. Back then, internet wasn't as like multiple people used to go to one room, lab room, from where you can access the computer. That was the state, and internet was really, really slow. So so now things are very different. You all have, and because now a lot of things you take for granted, mobile phones, WhatsApp, these kind of video chats. We didn't have any of those. But still, we studied computer science. So it was mostly server-related work. We used computers for computer games, local games, or LAN. But yeah, it was I think undergrad is the time when you learn a lot. And this is where I would say learn a lot about your field, learn a lot about other fields, and prepare yourself for even more studies after that. I always encourage people to don't just give up after undergrad. And don't just, you can take up a job, but within 1-2 years, go back to doing a master's, doing a PhD, because it's all about knowledge and learning. So during undergrad, just absorb a lot of information. Your minds are just going to absorb a lot more, and figure out what is it that drives you, what is your passion, right? And like networking was a passion that I realized when I was then. It just gave me a lot of excitement. I got very excited whenever it was anything to do with sending bits across to computers. So that, I think, that has stayed with me throughout, even now. I just get it. Like these days, we're starting something new on space communications and research around that, because that's going to be the future. And so we are starting some work in that space. But yeah, undergrad life is a fun time. study hard, but also grow outside of studies. Try different things, make new friends, and read a lot, play a lot. Yeah.
I see.
Yeah.
So when you were coding mostly server-sided, was it like mostly C programming, or did you actually mess around with Ruby and other languages like that?
Oh, back then we didn't have Ruby.
Oh,
Back then in undergrad. These days we do. These days, yeah, we do a lot of Ruby, Python, every new language that comes
yeah.
up. Back then it was a lot of assembly code and C++ was coming about. So
Huh.
C sharp wasn't there and all that. Java was there. So it was either Java or C++ or assembly language.
Okay.
A lot of which today many students don't learn that, which is fine, I think. But
Hmm.
uh, yeah, back then that was the state of the art.
I see. Um, Before we move along to the talk to the participants, if you have any queries or questions, message me privately in the chat box. We'll address them later in the ending in the Q&A session. Okay, sir. So where would you like to begin?
Yeah, so let me begin. I was thinking about what to give a talk about, right? And you love and Raida was organizing this as
Yeah.
well. And I thought a lot. I thought a bit about today about whether I should use slides or not. I decided not to. I decided to just tell my story along with some of the what I'm passionate about, right? And I'll
Yeah.
talk about digital agriculture because I think this is something that a lot of you. I just wanted to make you aware of this problem. This is a hard problem. I
Yeah.
also wanted to talk a little bit about how, as a computer scientist, I'm looking to address that problem,
Mm.
looking at some of the things in networking, in artificial intelligence, and how we are working in an interdisciplinary way, working with people in different departments in agriculture, in chemical engineering, in electrical engineering, and everyone coming together to try to solve this problem. But we are still scratching the surface. I think
Yeah.
all of you who are now doing your undergrad, I want to motivate you to think about this problem. It's not when we think of food, when we think of farmers, it's not just an agriculture science problem. All of us can play our role to help address that problem. So I could start by telling something about myself. So I did my undergrad from IIT Kharagpur in computer science. I am originally from Jamshedpur. Jamshedpur is Steel City. I don't know how many of you know that. It's
Huh.
in
Yeah.
Jharkhand. Jamshedpur is actually the only city in India without a mayor. So it's run by the Tatas. So
Okay.
it's a very pretty city with like we had 24-hour water, 24 electricity growing up, which was
Yeah.
a luxury back then. I'm assuming even now. So after that, I did my undergrad from IIT, and then I came over for my PhD at Cornell. Right after that, right after my undergrad,
Yeah.
you would ask, well, did I know that I wanted to do a PhD? Well, I can be completely honest here, right? That is, back then in from undergrad, the top few people would all apply for a PhD. I didn't want to do a PhD back then. I was like, I just went with the flow, and I was like, I really wanted to do an MBA. I wanted to be. I thought I would be really good as an MBA in business,
Yeah.
not in tech. But I ended up there. There was this professor at Cornell
Mm.
who really, I really loved his research. I wanted to go there for him. I had
Yeah.
other offers. I had Carnegie Mellon and a few other places, and I did not. I wanted to go to.
Yeah.
I picked Cornell because of him. I landed at Cornell. This was right after my undergrad. I'm fresh in the US. I pinged this professor saying, "I want to meet you because I've picked Cornell and I was assuming that I was going to be working with him. But this was the dot-com boom time, and he said, "Oh, sorry, I just decided to leave the university." So I
Oh.
was like, "Why did I come here?" I was feeling a bit upset. I was also thinking of Princeton at that time. But
Yeah.
then there was another very senior professor who adopted me. He was like, "See, you have a fellowship. You can do whatever you want." And that kind of during that time, this is right as you go, right? You go to a new
Yeah.
country and you're told that, hey, the guy I want to work with is not there. But that freedom that I got during that time is the time when I really enjoyed the fact that I picked doing a PhD. No one was telling you what to do. It was a lot of freedom. my advisor. He was more like a mentor. He would brainstorm but not tell me what to do. And that freedom is something which I really liked. And after my PhD too in research, after I joined Microsoft Research, very it's been that way even now, that if you join research of a company, you have a lot of freedom to do whatever you want to do. So, anyways, now going back, I did my PhD in computer science at Cornell. I built a technology called virtual Wi-Fi, which was basically, if you think of it, when you have to connect to a Wi-Fi network, what do?
Yeah.
You click on this Wi-Fi icon, you pick a wireless network, and you connect to that wireless network.
Yeah.
That's the way you connect to a Wi-Fi network.
Yes.
In virtual Wi-Fi, what we built was a way where instead of one, you could select multiple Wi-Fi networks to connect. So you could
Okay.
connect to multiple of them, and we built the system. And right when I was graduating from Cornell, this was in 2005. At that time, I mostly interviewed in academia. I had offers from UT Austin. I had offers from a few other universities, Rochester, Washington University. The only industry place I applied to was Microsoft Research, because here I was told that I could ship my PhD work as a product in Windows 7. So that's why I decided to come to Microsoft. After I joined, it actually shipped in Windows, and then we also licensed this tech out. Like, for example, if you're using your personal hotspot on your
Yeah.
Android phone or your Apple phone, behind the scenes, it uses a technology called Wi-Fi Direct. And that is built on this technology called virtual Wi-Fi. So the reason, right after I graduated, that was the reason I joined Microsoft Research.
Yeah.
And after I joined Microsoft Research, I've been here. This is my 16th year at Microsoft. And over the years, I have been doing various types of research, like TV white spaces was one of the things you mentioned. And actually, after I joined Microsoft Research, which is the research arm of Microsoft. We have a few hundred PhDs in different parts of the world. And at Microsoft Research, this was set up in 1992 by Bill Gates. And when he set it up, Microsoft Research had three key missions. The first is to advance the state of the art. That is, we publish openly. We publish a lot of our research, a lot of new things that we do. We keep it out in the open. We file patents. I serve on PhD committees of various students. I've advised various students in different universities.
Mm.
So that's mission number one. In my own case, like I've published over 100 research papers on different things. Like you mentioned a few of those. The second mission of Microsoft Research is to make sure that the technology that we develop ships as part of Microsoft products. So one of the things we do is like in my own case, like you talked about Xbox, FarmBeats is a product, software-defined batteries shipped in Surface as well in Windows. So we do that. That's the second mission. And the third mission of Microsoft Research is, the way Bill Gates had defined it, was to make sure that Microsoft has a future. So we are encouraged to think of things that are 5 years down the line. So in my career, every 5 years, I start a longer term project. So starting 2005, I started the TV White Spaces project. In 2010, I started work on energy and batteries.
Yeah.
And starting 2015, I started the FarmBeats project. I know it's 2021.
Yeah.
The new bet I'm making, there are two bets I'm making right now. One is on space and the other is on sustainability. Let's see which one. I'm doing both.
Yeah.
And actually now it's more than me, it's my team doing a lot of work. So now that's been my trajectory, right? I've been here, but I work very closely with academia. I right now I am actually moving back to Microsoft Research. I'm leading all of networking research at Microsoft, and I'm also starting a new initiative called Research for Industry, where we'll be doing research across different engineering disciplines for different industries, for retail, financial services, agriculture and food, energy, and so on. So now let me talk a little bit about FarmBeats, right? I think that's something which I want to
Yeah.
just talk with all of you about and get your feedback too. And I'll try to finish by around in like less than half an hour so that we have time for Q&A. So the so with FarmBeats, what we wanted to do was try to address the world's food problem. So what is the world's food problem, right? The world needs more food. That is, if you look at the population of the world right now, by 2050, you'll have over 10 billion people. You have many more people, so you need to grow more food. How do you get more food is fundamental question, right? You don't have more arable land.
Yeah.
The water levels are going down. The soils are not getting richer. So how are you going to grow more food? And it is not just about growing more food. You have to grow good food, nutritious food, right? You have to give people good food. And you have to get there without harming the planet. So that is the fundamental problem. It's like the green revolution all over again. How are you going to grow good food and more food for everyone? Now, the agricultural scientists and the agricultural community has been after this, and the most promising approach seems to be that of data-driven agriculture. What do we mean by data-driven agriculture? We mean the ability to capture large amounts of data from the farm, from the entire food chain. And if you can capture this data, you can then use it to make very intelligent decisions, right? So, by the way, when I'm talking about all this, let me put a caveat before that. My background, as I said, is not in agriculture engineering. But I work a lot with people who are farmers or agricultural scientists. But that said, one of the other questions you might have is, why am I doing this? What's my passion? So I told you I grew up in Jamshedpur, but growing up, I spent a lot of time in my grandparents' farm in North Bihar. So in Bihar, near Bhagalpur, it used to be quite an expedition to go to my grandparents' farm back then. We had to take from Jamshedpur, we had to take two trains to this place called Munger, and from there we used to take a bus to Bhagalpur. We used to take After that we used to take another bus to go to a small town called Amarpur, and then take a tum tum, like a horse cart,
Yeah.
sit on that to go to the village, to my grandparents' farm. And it used to be, the last part used to be the most fun part, because invariably we used to have to cross a river, and we had to go on a bridge which was called a Tutti bridge, which was a broken bridge. So
Okay.
invariably when you're going there, you had to step off, go down the river, cross the river to the other side. It was quite an expedition. So the reason I'm telling you that is that when I used to go to my grandparents' farm, I spent like every summer and winter vacation growing up, I would go to my grandparents' farm. And back then, I hated anything to do with agriculture. I did not like it. That is, these villages, they did not have any electricity. They did not have any toilets. It was in the middle of nowhere, right? And so the rest of the year, I'm in Jamshedpur, and then 3 months of the summer, 1 month of the winter, I'm in this small village. So I did not like it back then, but those days, those vacations exposed me to a lot of poverty and a lot of primitive forms of agriculture, like farmers using bullock-driven tractors. And like the images which are very vivid in my mind are my mom, she used to do puja, and she
Yeah.
used to keep the offering after that, right? The prasad after
Yeah.
that, she would keep it out, take it outside, and there would be a group of people just waiting to pounce on the food because they were so hungry, right? And
Yeah.
that's something which has stuck in my mind. And that's something which I really want to alleviate through all of my research. And the white spaces, which I'll cover in a bit, is related to that. Energy is related to that. And farm beats directly related to improving farmers' lives. So that is my personal reason why I am attached to this. Now, going back to the thing about data-driven agriculture, right? I talked about how we need to grow more food. Now, one way to get there, as I was saying, is data-driven agriculture, which is about, can you enable farmers to use data to take their agricultural decisions? Let me give you some, like, what is the state of the art, right? So when I started the Farm Beats project, I went and interviewed several farmers worldwide. I even volunteered on a few farms. So what I realized is that these farmers, they know a lot about their farm. Many farmers, like some of them have been farming there for decades, if not centuries. There's one farmer who could feel the soil and tell you what's going on in the soil. There was another farmer who could taste the soil and say what's going on. These farmers, they know a lot about what's going on in the farm. The thing is, even though they know a lot about the farm, the soil, they still, a lot of decisions they make is based on guesswork. like when to plant, when to harvest, when to sell, what to plant, when to water, when how much to water. All of this is based on guesswork. The goal of farm beats is to enable data-driven agriculture. That is the future that we envision, is that we want to augment a farmer's knowledge with data and data-driven insights. That is, they know so much about the farm. If you can tell them what's happening where in the farm, they can use that knowledge to take very good decisions about what to do where in the farm. And that is the kind of thing we want to enable. Like this data could be things like in your farm, where should you be applying water? Where should you be applying pesticide? Where should you be applying fertilizer? This kind of thing, if you can build, say, a map of the farm using data and AI, a farmer can then use technologies such as precision agriculture. What is precision agriculture? Precision agriculture is the site specific application of inputs. That is, right now, if you tell a farmer to apply water, they will uniformly apply water throughout in the farm. But what they should do is they should apply water only where it is needed, as much as is needed, when it is needed. Same with nutrients, same with pesticides, same with everything, right? So that's the kind of thing that we want to enable with data-driven agriculture. So the benefits of data-driven agriculture are well known. Like precision agriculture was proposed back in the 1980s, and it has been shown that if farmers use data-driven agriculture, it can help them be more productive. That is, they can grow more. It helps them reduce cost because they use less water, less pesticide, less nutrients.
Yeah.
It's also better for the environment for the same reasons.
Yeah.
That is, you're not wasting water, you're not wasting pesticide, you're not putting more chemicals than needed. The thing is, despite the fact that these benefits are well known, these technologies haven't really taken off. The data driven agriculture technologies haven't taken off. And the biggest reason they haven't taken off is because of the cost of these data driven agriculture solutions. Like, let me put this in perspective. And I started this project in 2014, and around 2016, 2017, I'd gone to UC Davis, University of California, Davis,
Yeah.
and there was an expo going on. And there were several, that's a very good agriculture university. And there were several agriculture companies talking about what they have and showing their equipment. And the cheapest sensor package that was available there were 5 sensors for $8,000 and a recurring cost. At that price point, at $8,000 and a recurring cost, most farmers worldwide don't have the money to afford that. What is the ROI? What is the return of investment? If you buy one sensor and put it in the farm, you're not going to be, it's just way too expensive for them to even start adopting these technologies. And that has been the biggest blocker in the adoption of data driven agriculture solutions. So when we started the Farm Beats project, we kept a very bold ambition. We said that, can we bring down the cost of these solutions by 2 orders of magnitude? So we started inventing technologies. We're like, okay, let's go after this problem. What's the fundamental reason existing solutions are so expensive? So I'll talk about a few ways in which we are helping to bring down the cost. So one of the reasons existing solutions are expensive, that is, these ag tech solutions are expensive, is because of connectivity. Most of these farms, they don't have great internet connectivity. It's still expensive. Like even in the US, the farmer's house has some sort of connectivity to the cloud, to the internet, but the farm could be a few miles away. How do you send data from the middle of the farm to the farmer's house? Not just sensor data. This could be drone data, tractor data, camera data, all of this, large amounts of information. How will you transmit from a farm, which could be a few miles away, to the farmer's house? To address this problem, one of the technologies we use, which we just briefly mentioned before,
Yeah.
is TV white spaces, right? So I've been working on TV white spaces since 2005. What the TV white spaces enables is, imagine if you have a Wi-Fi router, like the Wi-Fi in your house
Yeah.
on which you're all connected. Imagine if you had a Wi-Fi connection that you could access a few miles away. That would be cool, right? Right now, as soon as you go outside your house, your Wi-Fi disappears. If you could access it a few miles away, that would be huge. And the way we did that was we took a Wi-Fi signal and we put it in empty TV channels. This is TV you watch using antennas. Most of you don't watch TV using antennas, but you might have seen others have these antennas on top of their buildings. And the thing is, most of the interesting thing is that in the TV with those antennas, that TV transmission is in UHF and VHF
Yes.
part of the spectrum. Yeah. So compared to Wi-Fi, in UHF spectrum, your signals would go 4 times farther. In VHF, they would go 12 times farther. This is purely based on physics and free space. Once you put in trees, crops, canopies, your signals just keep going through. And the key tech we built was a way in which you could send these Wi-Fi transmissions on a TV channel so that you could be watching, say, channel 7 at home. On channel 8, we could be sending Wi-Fi signals. And we would send it in a way that doesn't interfere with your transmission on an adjacent channel. So we built this technology, and then back in 2010, the FCC chairman had come to see the demo we had put together, and this was made legal in the US back then. And since then, we've gone out, connected high schools, hospitals, dispensaries in different parts of the world using this technology. And we've really, in fact, in 2017, Microsoft launched an initiative called the Airband Initiative, through which we've made a pledge to connect 3 million rural Americans and worldwide tens of millions of people to broadband using this technology, using the TV white spaces technology. There, just let me add a little bit more about why is this such a hard problem, such an important problem. So currently, more than 40% of the world's population doesn't have access to the internet. It doesn't mean that there is no internet connectivity there. It's just not affordable for them to access that kind of connectivity. With TV white spaces, we believe that we can reduce the cost significantly. We can democratize this kind of connectivity to the farmers. So that is one of the technologies that we are bringing to significantly bring down the cost to make data-driven agriculture more affordable. That's one. Then the other thing we are doing is, well, I talked about how we reduce the cost of connectivity, but suppose another problem is, suppose I have a farm, and the question I posed to you was, what is the soil moisture level 6 inches below the soil throughout the farm? How would you go about building such a map, right?
Yeah.
Like for a farm, how would you build a map of soil moisture 6 inches below the soil? Well, you can put sensors in the ground. But the thing is, if you put sensors in the ground to measure soil moisture, you would have to put a sensor, say, every 10 meters because your soil moisture just varies row to row. So how do you build a map? The question we asked was, well, you can't put a sensor every 10 meters because that's going to be expensive to deploy, to manage. It will also come in the way of the farmer as the farmer does a day-to-day job. So the question we asked then was, can we build a map like that using very few sensors? Can you, if you have a farm, can you just put very few sensors and still build a map? And our key idea there was to use drones. These are UAVs, you can buy them for a few $1,000s, and they have a camera at the bottom. And then what we did was we used AI to use aerial imagery, say from drones or satellites, where if you have a few sensors in the ground, we then use artificial intelligence so that with aerial imagery, the places where you have the sensors, and for those places, we look at the imagery, not just multispectral, but hyperspectral imagery as well.
Yeah.
We use that to train the model, and then we use that trained model to predict what these values are in other parts of the farm. And we did this, we wrote a research paper on this, and we showed that using aerial imagery in combination with these sensors can give you results that are 3 times more accurate than if you did not use aerial imagery. So what this means is, with TV white spaces, I talked about how you could reduce the cost of connectivity. With this, you need much fewer sensors than what you would otherwise need to build these accurate maps of the farm. So this is another way we bring down costs. There are many other technologies that we are building as part of. One of the things is edge compute. That is, rather than sending all of this data to the cloud, you could have a computer sitting in the farmer's house or office doing a lot of compute so that you don't have to send all of the information to the cloud. And with that, we can then start doing a lot of artificial intelligence, a lot of computer vision in the farm itself, getting all of these benefits to the farmer. Some of the things we are able to do, for example, is a farmer can put a low-cost sensor in the farm, and then we combine that sensor data with weather station data to start providing very hyper-local information about what's happening in the farm. So what you can then say, there's this farm in Eastern Washington. This is a fifth generation wheat farmer. He farms 9,000 acres spread across 45 miles. And right now, whenever he takes his tractor out, he looks at what is the predicted wind in different parts of the farm using our technology. Because if he's going to spray, say, any chemicals in the farm, he doesn't want it to be very windy, because then it won't go where he wants it to go. It'll spread out everywhere. So we are able to make these hyper local predictions of what's happening to help the farmer take the decisions. Another work we did to bring the costs down, this was uh, I talked about using drones, right? So you could use drones to get imagery of the entire farm. Well, drones are great, but they don't really work as well in remote farms in, say, India or sub-Saharan Africa, because drones, one, they still cost over $1,000. Most of these farmers won't be. They have limited battery life. Most of these commercial drones, they only last, say, 30 minutes on a single drone flight. And drones have many of these issues, right? They also have regulatory concerns. There was a country in Africa where we wanted to do a trial. We went and talked to the government, and the government was like, well, you need to get permission from the Ministry of Defense. Well, Ministry of Defense will never let you do it with all these trials. So there are many issues, right? So then the question we asked was, is there a low-cost way to get aerial imagery for a farm? If you cannot fly a drone, how do you get aerial imagery for a farm? So we decided to go low tech. You know what we built? We used a balloon, like a 4 feet balloon, which is tethered to the ground, right? It goes 150 to 200 feet. What we built was a mount, which is attached to the balloon. So suppose this is the balloon, there is a mount, there is a weatherproof mount on which a farmer can put their smartphone with a battery pack attached to it and the camera facing down. And this thing was launched at 150 to 200 feet, and someone could just keep it there, and this thing can keep taking images of that same part of the farm. In fact, if you have to see this, you should check out Bill Gates came to the farm. There's a demo farm here. Bill Gates came to the farm and he wrote about it in Gates Notes. You should check out his blog, and there's a video of him actually carrying the balloon. So the interesting thing about the balloon now is that your balloon with helium and a phone with a battery pack can stay up from 4 to 7 days taking images of the same part of the farm. So there was a farmer with whom we worked here. He was a small farmer. He used to sell vegetables in the farmer's market. And right now, his farm was next to the river. So every winter, whenever there was a flood, every morning he would come. If he saw any amount of flood in the farm, he would throw away all his crop. Because based on regulations, he didn't know what other crop was touched by flood. So he would just throw away everything. With this balloon, he actually knew which crop was touched by the flood. There's visual proof. So he can keep the rest of the crop and only throw away the crop that was touched by the flood. And in fact, we just don't stop here. What we did was, in places like India and Africa, where labor is inexpensive, someone could just walk around with the balloon or put it on a bicycle or a tractor. And you can then just cover an entire farm, and you have this visual image of the entire farm. So then we use computer vision techniques to stabilize the image. Because, with a drone, your camera is stable, always facing down. If it's a balloon with wind, your camera will go this way. It's not always facing down. So we had to use some AI to stabilize the imagery, and we use that to build these orthomosaics, these panoramic views. So these were some of the things that we built, which are very custom for places, for smallholder farmers, to the end goal being, can you bring down the cost of these data-driven agriculture solutions? In fact, there is a recent work I'm very, very excited about, is that right now we built FarmBeats, and so let me get to this in a bit. So with FarmBeats, this was in research for quite a while, right? So from 2014 to 2018, we did this in research. In 2018, I moved over from Microsoft Research to Azure, and then we had an engineering team. We actually shipped the product. Last year, we announced a product. This year, we've made announcements with partnerships with various companies. With Land O'Lakes. Land O'Lakes is a big cooperative in the US. We are working with them on, so all their digital solutions will be on FarmBeats. We're partnering with USDA, with PepsiCo, with Corteva, with various companies. Corteva's DuPont. we're working with many companies, and they are building their solutions on top. The way we are taking FarmBeats to market is not a farmer-facing product, but instead we are building it in a way where existing agricultural companies can then start building their agricultural solutions on top of FarmBeats. So we did all of this, but the next phase of my research is focused on further bringing down the cost of these data-driven agriculture solutions. That is, I talked about using all these technologies to bring down cost, but it is still not at a price point where many smallholder farmers would benefit from it. We need to further bring down the cost. So one thing which I'm super excited about is the latest paper we published on using Wi-Fi to sense soil. So the problem is the following, right? So suppose you have to put a soil sensor in a farm. The soil sensor right now costs a few $100s, maybe even up to $1,000. Yeah. Most farmers in places like India and Africa are not going to spend $1,000 to buy a sensor for the farm. But so that was the fundamental problem. How do you reduce the cost of these sensors? So the key idea was to use Wi-Fi to sense soil. So the idea was that most farmers, they won't spend a few $100s, but many of them have a smartphone, even if it is an inexpensive phone. Yeah. If it's a smartphone, it has a Wi-Fi chipset in it. If it has a Wi-Fi chipset in it, the key idea was that you could then use the time of flight of a Wi-Fi signal to measure soil moisture and soil electrical conductivity. So the vision that we had was someone should be able to bring their phone close to soil and it should tell you what the soil properties are. It sounds like science fiction. It sounds like magic. So underlying that, the key thesis is that the time of flight of your Wi-Fi signal depends on the permittivity of the material. So if my soil is moist, it's going to take longer to traverse the same distance, right? So, but the challenge is that this time is in nanoseconds. How will you measure that time in nanoseconds? For that, you need a wide bandwidth, which is not there in Wi-Fi. So to solve that problem, our key insight was that most of these phones, the Wi-Fi chipsets, have multiple antennas. So instead of measuring the absolute time of flight, if you measure the relative time of flight, you could then use that to estimate soil moisture and soil electrical conductivity. So we wrote a paper on this, which in 2019 in ACM Mobicom, which is a top tier computer science conference, it got an award at that conference for this research finding. In fact, when we showed it to Bill Gates, the title of Bill Gates's blog is "Can the Wi-Fi in your phone feed the world?" It's based on this. Yeah. So this was some brand new research that we did. But the vision here is that anyone with a phone, a farmer with a phone, can then know what's happening in the soil, can then know what's happening with their crops, so that they can then take more data-driven decisions to be more productive. Right? So that's something new that we are doing that I'm super excited about, on using technology such as Wi-Fi to really democratize sensing. So this is where we are. So I won't take much more time, but at this point, despite all the work that I'm talking about, we are still scratching the surface with respect to what we can do for agriculture and food to help solve the world's food problem. There are many, many open problems. That is, with just the amount of data that you can get, how do you really bring down the cost of these data-driven agriculture solutions? So the vision is the following, right? What are we after? With what you want to do is you want to be able to map a farm and be able to say what's happening in each inch of the farm, not just above the soil with the crops, but below as well, below the surface of the soil. And you want to do this not just what's happening now, you want to be able to tell what's happened in the past and what's going to happen in the future. If you can do this, you can tell a farmer whether there's a weather event going to happen, whether they should be prepared for it. You can tell a farmer what they need to do so that they can be more productive and they can grow food that is best for you and for them and for the world. So that is the vision, right? If you think of it, if you have to create that map at the lowest cost, without putting many sensors in the farm. So towards that, we are all going after that problem. It's a very hard problem, but but this is where technology needs to come in, and it's for everyone. It's for computer scientists. It's for electrical engineers, chemical engineers, because you do chemical
Chemicals,
sensing. You
yeah.
do mechanical engineers. There's a lot of robotics in here because you could automate a lot of things. So whichever discipline you are in, it is related to this problem. And I would really encourage all of you to work towards it. And I would just like to end with another problem where all the things I'm talking about is very related to that as well. It's that of climate change. So, as many of you know, so with climate change is one of the reasons we are facing this problem of climate change is because of the greenhouse gas emissions, and there are different industries that are causing a lot of these greenhouse gas emissions. There's the energy, the tech sector. Everyone is causing emissions. Automobile sector,
Yeah.
and when and Microsoft, we've realized that we have a role to play. So in January in last year, in 2020, Microsoft made a very bold commitment. We said that by 2030, we are going to be carbon negative. What that means is that we are going to be putting more carbon back into soil than the amount that we generate. So I don't know how many of you are aware of the carbon problem, so the
Yeah.
climate change problem. The At a very high level, carbon above the soil is bad, carbon in the soil is
That
good,
is good.
soil
Yeah.
and water. Right? The question then is, how do you put more carbon back into soil? So at Microsoft, for example, when we made that commitment, one of the ways we are planning to get there is by reducing our own emissions, but that's not going to be enough. We are
Yeah.
also investing in technologies to put more carbon back into soil. And one such industry that can help put carbon back into soil is agriculture. That is, if you with these plants, because of the roots, what they do is, as you know, because of photosynthesis, they take carbon, they put out oxygen, and because of the roots, they actually store this carbon. If farmers use the right agricultural practices, they could be putting more carbon back into soil. So, and then again, but how do we convince farmers to be using the right agricultural
Yeah.
practices? Things like no-till, reduced-till, cover cropping. And there again, if we could enable data-driven agriculture, it's not just about helping the farmers be more productive. It's not just about us getting better food or others getting better food. We can also play a big role in helping solve the world's climate problem, right?
Yeah.
So, and this is where my call to everyone would be: think about this. This is one of the problems where each one of you can play a very, very important role in helping address the world's food problem.
Yeah. Okay.
Yeah.
Thank you, sir. It's wonderful speak. I really love the part about the balloon though, because I love ideas which are like simplistic yet out of the box. Like, but I do have a question to ask. You said you keep data centers within the farmer's place itself, right? And you gave an example of a farmer who had 9,000 acres of farmland. Wouldn't that be generating exabytes of data? And standard with white spaces can only maximum transmit of up to 40 Mbps. Am I right? Like 40 Mbps is like the transmission bandwidth. So if you, how do you to like control exabytes of data? Wouldn't you need like a really powerful system, and wouldn't that be expensive?
Right. No, so what we're doing is, so what we're putting in the farmer's house or office is an edge computer, not the complete cloud. So the cloud is still in the big data centers that we have. In the farmer's house, it's like a PC. It's not, and the amount of data, it's of the order of tens of gigabytes.
Okay.
So in the farm, so it's of the order of tens of gigabytes with drones and tractors and all. So that makes it more manageable. And then the TV white space bandwidth right now is about 100 megabits per second downlink. So
Hmm.
that's working reasonably as well. So that's where I think it's more tractable to run computer vision techniques on these kind of edge processors. But that's right now. Who knows in the future when we go to even micro level data, whether we'll be getting even much more data.
Yeah.
For example, if you start introducing robotics in the farm,
Yeah.
and yeah, like one of the John Deere tractors had multiple GPUs running simultaneously on some of the AI algorithms. So
Yeah.
maybe the farm of the future could look very different if once you start capturing even more and more data.
I see.
Yeah.
Oh, I like that answer. Okay, with that, can we start a Q&A session?
Yeah, let's do
Okay.
that. Yeah.
Um,
I would love to even interact more with students as to who all are there, what's their background. Would love for
uh,
people, by the way, people on the call, do feel free to connect with me on LinkedIn, and would love to chat with you about what you're doing. And yeah, I really enjoy this part of the meeting students, by the way. I give a lot of talks in universities. I'm scheduled to be at Carnegie Mellon in a couple of weeks. And then my best part of all of these meetings is the time I spend with students.
uh,
I would love to hear what's top of your mind. What are the things you guys are thinking about?
okay. Uh, I'm sure everyone is gonna text you as soon as this meeting is done. So, how does your first question would be, how does a regular work day look like for you, like in the Microsoft Office as a researcher?
You know, when you start as a researcher, the work life is very different than where it is now. Now my life has become too busy. I'll start with when, as a researcher, what it
Yeah,
looked like when I joined, right?
yeah,
So when I joined, I would think of a lot of time was spent thinking, ideating, prototyping ideas. That's what I would do. And reading a lot about an area, and interacting a lot with researchers, brainstorming on things. The best part of research is that you're always doing things that no one else has done before.
yeah,
You know, it's like a mini startup if you think of it. You're running a small startup with your idea with
yeah,
a company, right? And as opposed to if you go to a pure engineering role, it's important too. You need strong engineers where you're as an engineer, you're thinking about building a solid product based on what you're building that people can use. In research, you're thinking of the step ahead, what's going to come next. And a lot of that time is spent on ideating and thinking about things. These days, my life has become very different. It's a lot of time is spent managing teams and managing projects, talking to customers. I do a lot
yeah.
of customer meetings, understanding their problems. Yeah.
Oh, okay. And so you mentioned the idea of IoT farming, like for farmers. Basically, it's not been around for a long time, mostly because of how complex the concept is, and it's hard to implement it in a simplistic possible manner for because usually farmers are not the high earners in society, right? What does Microsoft intend on entering the Indian agriculture market? Because here there's like much lower budget and much smaller farms. So, but the machines and equipment will still be the same price. So, what is your thoughts on those?
Yeah, so with Farm Beats, we are not going directly to the farmer. It's not a product for the farmer. We work with agricultural companies who build solutions on top of Farm Beats, and they are the ones who take it to the farmer. So we are working with various companies in different parts of the world, including in India. In fact, I serve on the board of advisors for Tropin, which is a company in Bangalore, in India. And they're doing quite, they just raised Series C money, and they are building these data services for farmers in India. Essentially, the way they are building is they're getting a lot of data from the farm and then applying AI to start building these advisories for the growers. So this is from our standpoint, what we believe is that we need to bring more. That's You're right that the problem is different in the Indian context, and every geography, this problem is going to be different. And for us right now, we are working with the local partners and bringing all of the innovations, the kind of innovations that I talked about, to that particular country, to the farmers in that particular country, in this case, India. But that said, to make it really feasible for the sub-acre farmers, a lot of them are really smallholder farmers, we need to do more. And that is one of the things I was telling you, that there is a lot of new research, a lot of new ideation to be done to make these technologies really affordable for farmers worldwide.
Okay.
Yeah.
And sir, regarding TV white spaces, the
Mhm.
speed transmitted through the bandwidth is much better than what is there for 3G back in the day, and it has much greater range than any Wi-Fi so far. What was your eureka moment that gave you the inspiration to transmit it over white spaces? Like, what is the birth of the idea, though?
Yeah, so this actually started in 2005, right? When I was thinking about it came through Wi-Fi. That is, we were thinking of different parts of the spectrum. Wi-Fi operates in 2.4, Wi-Fi operates in 5 gigahertz. The key concept that we all started developing was this thing called dynamic spectrum access. That is,
Yeah.
right now, the government does spectrum auctions. You all hear about spectrum auctions, right?
Yes.
Part of the spectrum goes to 3G, part of the spectrum goes to someone else. But at any time, a lot of the spectrum is not used, even though it is allocated. So the key idea then was, well, a lot of spectrum is allocated. It's been assigned to say TV, but there's no TV transmission. Like in India, it's the classic example. All you have is DD and DD Metro.
Yeah.
The rest of the TV spectrum worldwide, it's been assigned to TV, and it's just fallow, nothing happening there. And in the US, it's also a big problem. So that is what led to the start of this project. That is, can we opportunistically transmit in this part of the spectrum?
I see. So mostly it was how to maximize efficiency on the spectrum. But
That's right.
currently, since they're using dish rather than the TV antenna, right now with the current technology, white spaces are not even required, right, for TV transmission.
Yeah, so you have a lot of spectrum. We'll get a lot of bandwidth if
Yeah.
we can use it.
So it's like almost
Yeah.
entire complete bandwidth you have to use.
Yeah, like in the US, I think right now there are only 6 million people or something like that that use antennas for TV reception. But even then, there are people, and these are still people who
Yeah.
still watch TV using over-the-air antennas. So we need to support that. Yeah.
I see. Okay, next one's a pretty straightforward question. What's your favorite part about being a scientist? Like, is it like how they show in the movies that you just like, haha, I invented stuff?
That's a good question, right? What's my favorite part about being a scientist? I think what I like, a few things. One, I think I what I like is that I'm going into places which no one else has been before. I really like that. That gives me a thrill. And the other thing is that I think I'm able to the fact that you're able to do things to serve people. That is, I said, right, that is this time that I spent in Bihar has been kind of the motivating factor for everything I do, like with TV white spaces to energy to farm beats. And the fact that I'm able to address and at least take a step forward for in any of these problems, and based on some new invention like the balloon idea or the Wi-Fi sensing idea or TV white spaces or any of these AI things, being able to go after problems that are really important to solve for humanity and do it within Microsoft, where I'm also able to make a business case for it. I think that's something which I really enjoy, where it's science, but I'm not just doing science to publish a paper. It's science to be able to do something so that within Microsoft, we're able to then take it to the people to help change their lives. I think the biggest satisfaction comes from that. But the scientist piece, yeah, the fact that I'm able to just go in areas that no one else has been before. And I also like the fact that there's no one telling you what to do. In a
Yeah,
work environment, you're kind of your own boss. So that's
yeah.
again another reason. I think, yeah. If anyone of you are thinking whether to do a PhD or not, I can convince you to do one. So we do. Yeah.
Yeah. Um, what has surprised you most in this journey of yours?
So the fact that I'm still around hey man, by the way, you should have told me these questions beforehand, but I'll just tell you.
No, they're coming up as the talk went on. So,
No, no, this is good. I can answer as they come up, right? So the question was, what has been the most surprising thing in my journey, right? So one of the surprising things is how long I am at Microsoft. I never expected that. The fact that I did a PhD, I never expected that either. When I told you, right after undergrad, I thought I would do an MBA and be like that path.
yeah,
Path. So that has surprised me that I did a PhD, and I liked the fact that I did a PhD. Um, even though now, that's why, like most of the research that I do, I try to bridge research with a business model so that it aligns to something which is also a business as well as it's new, like a startup to some extent, right? So I think that has been surprising too. That yeah, one part was I've stayed at Microsoft for so long. I've always wanted to step out and do a startup or go to academia because I enjoy
Yeah,
teaching. So but I'm still here, and I just
yeah,
took on a new role. So that's something which has surprised me as well. And yeah, the other thing is I love interacting with students, and that's where I think that it's made me more and more optimistic about what kind of new research can be done, right? And new topics. Like a lot of time, I'll give you like a few years back in the networking research community, there was this discussion going on: is networking research dead? That is, you have decent internet connectivity from the house, right? Most
yeah,
of you have joined this WebEx call. Do we need more research in this space, or are we mostly done?
yeah,
But what I've realized is that as things progress, more and more students keep coming up with brand new ideas, a lot of really good ideas. So all of this research areas in computer science, there is a lot of breakthrough happening and a lot more will happen. Well, that's not really a surprise, but that's more of a realization that
yeah.
how the research topics have evolved over the years and how they are evolving even now. Right? Yeah.
Okay.
But
Uh,
surprise-wise, I think I'm surprised by how long I'm here. And the fact that I haven't gone back to India yet, like to settle there. I've
uh,
always wanted that. Yeah.
uh, I have one of the participants had asked this question. So basically, when you're taking like areas in US and all, where it's like one farmer owns like a gigantic piece of land, so it's like almost like a city size. So he can have his own bandwidth and his own set of this thing range. It's like almost a TV range. Uh, what about for places which have like small farms and farmers who are to implement such systems? Uh, the TV spectrum only has like a certain limit, right? Wouldn't the white spaces occupied from one sensor and one farmer in particular affect like a sensor and a farmer from another?
Yeah, no, that's a good question, right? And this is a networking question. We wrote a paper on this, on
Yeah,
how do you coordinate across multiple networks in the same geography. Although typically what you would expect is for these kind of scenarios that there'll be a third party. It's a business idea, right? Someone
yeah,
else comes in and sets up these towers, and these farmers just share that connection as opposed to each farmer running their own Wi-Fi. You can imagine someone else setting it up and sharing it across everyone. And the other thing is that, Wi-Fi is meant to connect people. Here, what we are talking about is primarily connecting things, not connecting people.
yeah,
And there's some very interesting problems that come up, which I didn't talk about today when you connect things as opposed to people. We as people mostly download content. You're watching a YouTube movie, you're watching something on Netflix. It's mostly downlink. You're getting information. The Internet of Things, you're mostly sending information. Like a drone is capturing data, it's all uplink. It's all sending data. Same with cameras, same with tractors. So you need more uplink bandwidth and not as much downlink bandwidth
yes,
for the Internet of Things. So the network would look very different. If you look at 4G, even 5G, the way these networks have been defined, it's mostly downlink. It's meant for downlink traffic. The future networks, the kind that I'm talking about, will be uplink traffic. And you can see where in places like wherever you have small farms, you can see how this is a business idea where some rural internet service provider will come in and just provide this connectivity to everyone rather than every farmer putting it. Yeah.
I see. Um, Also, one of the key qualities of a researcher is patience, because research can be exhausting sometimes, right? Like, how do you keep yourself motivated? And also, like, basically, you mentioned freedom, right? That's the best part about being a researcher. But when you can do anything in the world, you don't know what exactly you want to do, right? Because the possibilities are infinite, so you don't know what to choose. What way do you want to choose something, and how do you stay motivated on that one particular topic without branching out?
Yeah, no, that is a challenge. That is a challenge. And I think it comes like there are um, you have to make the right bets about what you want to do, and usually go with some people who might know. Like in this case, that's I think if you were to ask me my strength, I think that's one of the places I think I've been lucky in that to make the right bets and to see what the right problem is. I think the way I do it is, but because there's so many problems out there, right? If you start listing the hard problems, you'll come up with many of them. The one thing I usually do is to pick ones that have a good business model associated, which is not just a hard problem for the sake of a problem, but a problem which, if solved, could also be a good business. And those are the bets that you should make, right? And and the other part is around having the confidence that it will work, right? That is, a lot of times, yeah, I can pick a very hard problem. I'll solve P equal to NP for computer scientists. But
Mm.
it's, will it happen? Who knows, right? You have to be pragmatic and pick the right problem and have. The other thing I do is that whenever I pick such a hard problem, I'll divide it into stages where there are certain things which are easier to, you're more likely to succeed,
Yeah.
you know what it is, but the end goal should be hard. What you're really after is something really hard. If you get it, you won. But even if you don't get it, you've made some progress. It's not a complete disaster. So that's also something. But yeah, to your point about freedom, you if freedom is double-edged, as you said, right?
Yeah.
You want freedom. It's great because then you know there's no boss telling you, hey, do
Yeah.
this, do that. But on the other hand, it could just randomize you, right? So that's where you need to work in a team, work with people where you can make those kind of bets. Like if you become a professor, you'll have that kind of freedom. Although in professorship, usually your freedom is limited by the grants that you get. Like you're then
Yes.
applying for grants, and the granting agencies kind of decide the big area that you're working on. So in Microsoft, in my case, I try to do things which somehow align to within the Microsoft vision, right? Like I did
Yeah.
make a bet, by the way. When I started FarmBeats, this was in 2014. I was told by my immediate manager that Microsoft doesn't do FarmBeats. Microsoft doesn't do agriculture.
Yeah.
It shouldn't be doing this here. So at that point, I really believed in the problem. So I wrote a memo. I escalated it all the way up. I was like, if this is not happening, I'm not staying here. So then I changed the manager. They gave me some resources, and that's how this Farm Beats project started. So at some point, you have to just believe in the problem, and as opposed to going directly for the job. You know what I'm saying? That is, in my case, I could have gone out and gotten funding for it too. So that
Yeah.
was my conviction that either I do it here. If Microsoft would have said you can't do it here, I'd have probably gone out and done it, right. So you have to have that conviction that
Yeah.
this is a hard problem. I want to spend the next 5 years, 10 years going after this problem. Yeah.
Okay. We love asking this question to our speakers. It's very cliche one. What is your favorite book? Like you read the book and you're like, wow, my perception of reality has changed.
Okay, there are a few.
Okay.
One is recently I read this book called Blitzscaling. It was on how do you take things and quickly scale up? How do you
Okay.
blitzscale an idea, right? So this is something which I think it's Hoffman Reed who's written it, and it's a Netflix founder, and it's a great thing for startup. Anyone who's looking to take it, because I thought I had to read this when I moved over from research to the product side. That is, if you have a research idea, if you've taken and built the first level of prototype, from there, how do you make it a business? So that was something that I'm reading more and more books in this space in about how to scale up, how to create even more impact with the work that you're doing. That is from science to taking it to the real world. Right? Because in my case, I don't just believe in writing papers. Writing papers is important, but what really gives me the kicks is if you can see people
Practical
using it.
applicability. Yeah.
Yeah, if like for example, if I'm seeing people play with an Xbox One, I'm like, man, I build it, right? So that gives me a lot of pleasure. With farm beats too, if I can get farmers to use it. So that's one thing off late. I'm reading a lot about as to how do you scale research from just being research to practice. The other book is a very different kind of a book. It's called Stumbling into Infinity. This is more on my spiritual side.
Huh.
So I do meditate a lot, and someone talked about patience. So I think a lot of my patience comes from the fact that I meditate a lot, and I spend a lot of time just thinking about just going deep within myself. And Stumbling into Infinity is about one of the spiritual teachers that I follow. But yeah, I'm very intrigued by that side of life as well, where to know more about what is life, who we are, what is our
Yeah.
purpose,
Yeah.
what is energy. All of us are balls of energy, and just trying to decode that. And that's something I keep thinking a lot about. So I love reading on that front as well.
Ah, I see. I have an Xbox One, by the way. So just Chinese.
You have
Uh,
what?
I have an Xbox One. I really
Oh,
love it
good,
also. um,
good.
yeah.
Yeah.
So everyone's familiar with the service side of Microsoft, like Xbox and like the other stuff, like Edge, etc. Right? But can you walk us through the product design part of it?
At Microsoft, right?
Yeah,
So
at
at
Microsoft.
Microsoft, so our product design has also changed over the years, right? So when I joined Microsoft, Windows would come out every 3 years. Every 3 years, you had a new version of
Yeah.
Windows, and Windows and Office were the big products at that time. And since then, and then we used to have three different engineering teams. It used to be developers, used to have testers, and program managers. That's how the entire teams were structured. Now it has become much more agile. Like you have new Windows versions coming out nearly every 6 months, right? You have something new as an update that you install. It's also very cloud driven, right? So everything is in the cloud, and we have very fast development cycles on that. And typically, the way we work is we every semester or something like every 6 months we'll think about we'll prioritize the big themes that we are going to be investing in, and we pick the right features that we are going to ship. And then through these engineering sprints, we go and we quickly build that out. And then typically for a product, we go through multiple stages. We start with a private preview. What that is a limited version of the product that we give out to customers to try. Then after private preview, we have public preview, where it is more available for everyone to use and with some pricing model attached to it. And then the final version of the product is called GA. It's generally available for
Okay.
everyone to use. So we go through those, but that's mostly for the software side. The hardware side is like the Xbox, the Surface, and all. There we
Yeah.
have a different path where we go through. Again, it's similar in the sense we prototype different versions of that. And as we develop the hardware, we keep building the software for it too. And then we again do limited trials of it before we ship it out for everyone to use. So, and with different teams, we realize that we need different engineering models would work with hardware, with software, with the cloud, with AI. You need different models. You need different ways to different time cycles to make progress on that. And that's the kind of thing we do. And this is what we call as like it's very agile. Like the one of the other things you might hear these days is CI/CD, that is continuous integration, continuous development. That's
Yeah.
you want to constantly be developing and constantly be updating and integrating your code so that you're never falling behind. And there's some very interesting software engineering challenges that come up. So anyone who's in computer science working on software engineering has some very, very interesting problems, and how to make the entire software developer's life cycle much faster, much more efficient.
Yeah. Also, sir, you had mentioned that the sensors you place in the ground, right? You place a few sensors and you ask AI to predict the rest of the farm. Speaking from a data perspective, I noticed like if you make prediction, like large scale predictions from a small data set, doesn't that usually lead to false assumptions and huge values of error? So how do you remove that error?
Right. No, that's a good question, right? So suppose I'll give you an example. If I have a farm and I have, say, 100 sensors in the farm, like a big farm, I have 100
Yeah.
of them. And with that, I'm trying to predict the entire farm everywhere, right? One of the ways you could try to address this problem of error is out of the 100, say you take 5 off, you use the remaining 95 to predict what the other 5 should be. Just
Yes.
like you're predicting the other points, you also try to predict the remaining ones. If they are outside of the bounds, is where you know your model is failing. And that's used as a trigger to then go and either get an updated visual image or retrain your model. That's the way we
I see.
do that.
Okay.
Yeah.
So this is our last question. After this, we'll be wrapping up.
Yeah.
So you mentioned about data-driven agriculture. You told us like how farmers have like a sixth sense and how they can sense the soil just by like of their farms just by like knowing and tasting. Does and you said you collect all this data. A part of it is in the system where the farmer is, and most of it goes to the cloud, right? Does Microsoft use the data gained from all these various farmers for like future predictions?
No, so we don't use the so the data doesn't belong to us, right? So the data typically is belongs. So if you're working with Land O'Lakes, right? So Land O'Lakes is the company that has a partnership with the farmer about who has the data, not Microsoft, right? So similarly, if you're working with a company, it's a partnership between that company and the farmer on who owns the data. What we provide is the mechanisms so that the data can be shared securely and the data is not leaked, is the thing that we are providing. But we are not using that data directly for our own models. Like a partner could, like a Land O'Lakes could, a USDA could, but we wouldn't do
I see.
it.
Um,
Yeah.
okay. Thank you, sir. You've been a wonderful guest. This concludes our fourth Newton Speaks and our first one of 2021. Seems like the perfect way to start the year. Thank you, sir. Thank you, everyone, for attending. We hope you enjoyed the session. I know I personally did. We hope you join us in our future editions of Newton Speaks with another engaging speaker. Thank you all and goodbye.
Bye.
Bye, sir. Thank you, sir.
Thank you.